Hey everyone, welcome to homework 1.2. So I'm going to go ahead and post probably the whole thing today, and you can use it all if you want to. Remember, it's due Friday. So number one says evaluate mentally, 25% of 200. Well, I can easily do this by saying, well, 25% of 100 is 25. So 25% of 200 must be 50. Then I'm looking at 12%. Again, 12% of 100 is 12, so 12% of 200 is 24. 8% of 200 would then have to be 16. And so I should see a pattern here. Now it says P percent of 20. These all represent P. And notice to get what it would equal, what did I have to do to get from this percent to this number? So I want you to think about that for this one and come up with your own answer there based on the pattern that you see above. Number two says these three figures are called platonic solids. So this tetrahedron, cube, dodecahedron, those are platonic solids. The table shows the number of vertices, edges, and faces for the tetrahedron and the dodecahedron, and then asks you to fill in that for the cube. So let me just review really quick. Your faces are your sides, okay? The vertices are your corners. And then your edges are the lines along the edge. Okay? And so when you're counting those, you're going to figure out how many of those there are. So let's take a look. Okay? If I am starting with my faces, I've got 1, 2, 3, 4, 5, 6. So 6 faces. Vertices, I have 1, 2, 3, 4, 5, 6, 7, 8. And then edges, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So, that's not a very good looking 12, but work with me, guys, okay? Here, let's fix it. 12. All right. So then it says, make at least 2 observations about the number of faces, edges, vertices in a platonic solid. You can make your own observations, right? So like our edges more or less than vertices, are the number of faces more or less than edges, right? So make a couple of observations yourself here. That's something you can 100% do. Number 4 says there's some interesting relationships between the faces, edges, and vertices in all the platonic solids. And so it gives you an example of an observation that you may have made. There is a relationship that can be expressed with an equation. Can you find it? If so, write an equation to represent it. So, when I'm looking at this, I'm thinking about what is the relationship between faces, vertices, and edges. Now notice in the tetrahedron, they're the same. The faces and vertices are the same, but that's not true in the cube and the dodecahedron. So what I'm going to do is think about what operations I'm going to use to get to the number. Right? So let's say if I were to do, for example, 4 times 4 is 16. Is there a way I can get from 16 to 6? Not really. If I do 6 times 8, I can get 48. I can do 48 divided by 4 gives me 12. Okay, can I do that with the bottom one? Well, 12 times 20 divided by 4, is that going to give me 30? So you have to work through that process of thinking through, does that work? Okay? We know 4 times 4 divided by 4 does not give us 6. So that doesn't work there for us, so we have to think through something else. So what I'm going to say is, well, let's try adding them now. So 4 plus 4 gives me 8. How do I get from 8 to 6? Well, I say 4 plus 4 equals 8, and then to get to 6, I do 8 minus 2 equals 6. Let's see, does that work for the next one? If I do 6 plus 8, I get 14, and then 14 minus 2 gives me 12. Oh, that does work. What about the next one? 12 plus 20 equals 32. 32 minus 2 equals 30. Boom, that also works. So you can see the pattern here is we're adding the face and the vertices and then subtracting 2, and that gives us the number of edges. So I'm going to ask for you to, now that I've showed you that relationship, can you write an equation to represent it? So knowing that information, knowing the pattern, can you write an equation using your variables to represent that relationship? Number 5, a large cheese pizza costs $5 each and 1 large topping pizza costs $6 each. Write an equation that represents the total cost T of C large pizzas, cheese pizzas, and D large 1 topping pizzas. All right, so we have $5 each for the cheese pizza, so that's 5 times the number of large cheese pizzas, plus $6 each for the number of large pieces equals T. Number 6, Jada plans to serve milk and healthy cookies for a book club meeting. She is preparing 12 ounces of milk and 4 cookies per person. Including herself, there are 15 people in the club. A package of cookies contains 24 cookies and costs $4.50. 1 gallon jug of milk contains 120 ounces and costs $3. Let N represent the number of people in the club, M represent the ounces of milk, C represent the number of cookies, and B represent Jada's budget in dollars. Select all of the equations that could represent the quantities and constraints in this situation. So you need to look to see, do each of these equations match information that we have in our problem? So looking at the first one, M, which we know represents ounces of milk, equals 12. That's the number of ounces of milk per person, so that so far checks out, times 15, which is the number of people. So A does work. 12 times 15 would give us the total number of ounces that she needs. Letter B says 3M, so 3 times the ounces of milk, plus 4.5C, so 4.5, which they got from the cost of the cookies, so 4.5 times cookies. But remember, C represents number of cookies, not packages of cookies, equals B, the budget. Ooh, so this isn't going to work because 3 is $3 per gallon, not $3 per ounce, right? And so this equation does not represent our situation. Letter C says 4N equals C. So this is saying that we have 4 cookies times the number of people, N, equals C, the total number of cookies. Yes, this does work because we have 4 cookies per person and we want to see how many cookies do we need total. So that is applicable. D says 4 times 450, so that's 4 cookies per person times $4.50. Now remember, $4.50 represents 24 cookies, not 4 cookies. So this does not work, right? Because that would not be true. And letter E says B equals 2 times 3. So that's, if we were to get 2 gallons of two jugs of milk times $3 plus 3 times 450. So 450 represents the number of, the cost of the cookie packs. And if we need to buy 3 cookie packs for $4.50 each, then that would give us our budget because it's telling us how much milk we need to buy and telling us how many packages of cookies we need to buy. How much that will cost if we multiply by $3 and multiply by $4.50. All right, number 7. A student on the track team runs 45 minutes each day as part of her training. She begins her workout by running at a constant rate of 8 miles per hour for A minutes, then slows down to a constant rate of 7.5 miles per hour for B minutes. Which equation describes the relationships between the distance she runs in miles D and her running speed in miles per hour? All right. So this one is interesting because it's giving us 45 minutes each day, but it's asking us for the miles per hour. So knowing that, there's a pretty obvious answer. There's only one answer here that makes sense because we need to convert from minutes to hours. All right. So we know she works 8 miles per hour. She runs 8 miles per hour for A minutes, but we want to convert miles per hour 2 miles per hour from the number of minutes that we know she's running, okay? So in looking at that, there's only one obvious answer, right? Think about the relationship of hour to minutes and select your answer based on that, thinking through why each of the other ones does not work. I'm not going to tell you directly the answer. That's your hint. That's your help there. There's minutes to hours, okay? Number 8, Elena bikes 20 miles each day for exercise. Write an equation to describe the relationship between her distance in miles D and her biking speed in miles per hour. So again, we have a minutes and hour thing here happening, okay? So you need to think about 20 minutes in hours is what? right? So we have 20 minutes out of 60 minutes equals 1/3 hour, right? That's 1/3 of the hours. So at a constant speed of 13 miles per hour for the entire 20 minutes would give us D equals 13 times 1/3. All right, you're gonna get not the like cleanest number there, right? But that's how we can represent that in the equation because we're looking at 1/3 of an hour. B says at a constant speed of 15 miles per hour for the first 5 minutes and then 12 miles per hour at the last 15 minutes. So we need to go ahead and convert each of those minutes to hours. So we have 5 over 60 is going to be 1/12. And then for the last 15 minutes, 15 over 60 is going to give us 1/4. Okay, and so then 15 miles per hour for the first 5 minutes is 15 times 1/12 plus 12 miles per hour times 1/4 of an hour equals your given distance. All right, so using that information, I want you to try and see what you can get for C using now, instead of miles, we now have a variable that you're going to use in place of those miles. Remember, first convert minutes to hours. It's the same as B, so that should be pretty obvious replacement there. All right, and then go ahead and continue your equation. So C, you're figuring out, oh, that was a very bad line, figuring out on your own using the information I gave you in A and B. All right, let's look at number 9. A coach for a Little League baseball team is ordering trophies for the team. Players on the team are allowed to choose between 2 types of trophies. The gold baseball trophies cost $5.99 each, and the uniform baseball trophies cost $6.49 each. The team orders G gold trophies and U uniform baseball trophies. Write an expression that could represent the total cost of all the trophies. All right, so we'll say total cost equals, and we have $5.99 for the gold baseball trophies, so $5.99 G plus $6.49 U. Now, a question for you that I want you to think about is, why can I not combine these two terms? So think about that. Why can I not combine these two terms? They have to remain separate, and there's a good reason, so think about why that reason is. Number 10, the robotics team needs to purchase $350 of equipment. Each of the X students on the team plans to fundraise and contribute equally to the purchase. Which expression represents the amount that each student needs to fundraise? So $350 of new equipment is being broken up by X number of students. So the amount that they each need to fundraise is going to be using which operation? Think about it. Okay. Whenever we have a whole total and then we need to think about each or individual, then we're going to be using our division here. So this would be that we are dividing that 350 divided by X number of people. All right, our last one. In a trivia contest, players form teams and work together to earn as many points as possible for their team. Each team can have between 3 and 5 players. Each player can score up to 10 points in each round of the game. Elena and four of her friends decided to form a team and play a round. Write an expression, an equation, or an inequality for each quantity described here. If you use a variable, specify what it represents. So the number of points that Elena's team earns in one round. Okay, so if they have 5 players, right, because it's Elena and 4 of her friends, so she has 5 players, and they can score up to 10 points each. The greatest amount of points that they could score would be 50. So it could be less than that too, though. So it's going to be S is less than or equal to 50, assuming that maybe one of them scores only 9 points or something like that. And this is where S is the score. Now another constraint here is S would have to be greater than or equal to 0. All right, so you could also specify that because right? They could all score 0 points and then they would have a total of 0. So it could equal 0, but it would not be negative. We would not have negative points per the game rules that we have in this description. Letter B says the number of points Elena's team earns in one round if every player scores between 6 and 8 points. So if every player scores 6 points in her team, that would be a minimum of 30. If every player on her team scores 8 points, that would be a maximum of, oops, there we go. Oh, my pen. Okay. We would have 5 times 8, which would give us 40. So in this case, then, the score would have to be less than or equal to 40, but greater than or equal to 30. And you can write that as one phrase, or you can write that as two phrases, okay? So if you were to write it as S is greater than or equal to 30 and S is less than or equal to 40, that would also be fine. A lot of times when we're saying an and statement, it's true for both, we can write it like this. All right, letter C says the number of points Elena's team earns if each player misses 1 point. So if each player misses 1 point, that means each person scores 9 points, and there's 5 people, so that would be 45. And then letter D, the number of players in a game if there are 5 teams of 4 players each. So if there's 5 teams of 4 players each, that would mean that there are 20 players. And letter E, if the number of players in a game if there are at least 3 teams. So if there are at least 3 teams and the minimum number of people is 3, then the number of players we'll represent with P has to be greater than or equal to 9. Now, could it be less than that? Yes, absolutely. But if there are at least 3 teams, then we could have players that are greater than or equal to the number of 9. We could also say that, it's 15, right? That there's a relation there with 3 teams and 15. However, there could be 4 teams, right? There could be 5 teams. And so then that number would be increasing and increasing, and we know that it needs to be at least 9. All right, so we don't need to add any other qualifiers other than P equals players. All right, that's it for your homework. For your code word today, your code word will be target. Target, since we are playing some kind of game in which we earn points in this scenario. All right, happy homeworking and see you later.